You all, my dear students. This is a third video on shear force and bending moment diagram. In first video we discussed about introduction. Second video we discussed about standard cantilever beam problems, and now we are considering mixed loads in cantilever beam. Okay, several loads, mixed loads that we are considering. Okay, the sign conventions you should know. That is, these are all the sign conventions we are using for shear force. This is a sign convention, and for shear reaction this one, and shear force this one, and bending moment this one. Right? Then very important thing you should remember here is whenever you are dealing with the shear force, when you come across with the point load, you have to take two sections. One left of the point load, and other one is right of the point load. Then the second very important thing is whenever dealing with a bending moment, when you come across with a moment, then you have to take two sections, one left of the moment and right of the moment. Right? Now we are there. First, we will consider shear force diagram. For shear force diagram, you should mark these points A, B, C, D already marked, and distances are also given and loads are also given. Okay. Now shear force. One very important thing about cantilever beam is always come from free end to the fixed end, and no need to determine support reactions in cantilever beams. Okay. Now shear force at D. At D I cannot take because point load is there. We have to take two sections as per this rule, that is left of the D and right of the D. First I will consider shear force right of D. Right of D means this is my right of D, and here I'll observations I will make right side. Therefore nothing is there, no forces are there right side of this section, therefore 0. The second point is shear force at left left of D. Shear force at left of D means now this is a left of D. Left of D, then observations I will make it right side. I will make it right side observation. Right side observation, I am seeing one vertical force. That vertical force is 800 Newton. 800 Newton right side means this one. Right side downward forces are positive, therefore this is positive force. Right on. Over. Next, I will come shear force at right of C. Why right of C? Because C is a point load, right of C. Then here I will take a section at this point. When I take section this point, then I will observe right side. When you see right side, observation right side. When you see observation right side, you are seeing only one force. This entire right side you are seeing again only one force, that is 800. Right side downward is a positive, therefore positive. Next one is shear force at left of C. Shear force at left of C means this is your shear force left of C. Left of C, when you see this one, then you are observing. Okay. When you see this one, then right side what you are seeing? Right side of this section you are seeing two forces, one 500 Newton, one 800 Newton. Therefore 500 Newton and 800 Newton. Both forces are downward. Right side forces downward are positive. Therefore plus plus. Therefore answer is 8 plus 5 13, 1300 Newton. Over. Next I will come to shear force at left of right of B. Right of B means this is my shear force diagram. Correct? These sections are gone. Now that is my shear force section. Section right side, what all forces I am seeing? I am seeing 500. I am seeing 800. These two forces, and both are right side downward positive. Therefore answer is 1300 Newton. Right. Next shear force at left of B. Left of B means this is gone. Left of B means this one, And right observation, you are seeing three forces. Those three forces are 300 Newton one force, 500 Newton one force, and 800 Newton one force. All forces are right side downward positive. They are resembling with this one, therefore positive. Then the total answer is 13 plus 6, 1600. 1600 Newton over. Then I will come to shear force at A. At A I can consider, at A means this one. This one right side I will see all these three forces again the same thing, and this is 1600 Newton. Okay na? Over. Now I can draw shear force diagram. Take one horizontal line. At this point, at D point, 10 and second one is 800. 10 and second one is 800. And after that, at C point, one 800 and 1300. One 800 and another one is 1300. This is 800 and this is 1300. And at B point, I have 1300 and 1600. 1300 and 1600. This is 1300, this is 1600. Now, no load, straight line, no load, straight line, no load, straight rectangle. Right? Now, this is your shear force diagram. Over. Now, we'll come to bending moment diagram. Now, bending moment diagram, there are no moments, therefore, as per this rule, no need to take two sections. Only one section at each point is enough. Therefore, bending moment at D. When I see at D, when I take at D, then section will be here. Observe right side, you are seeing nothing, 0. Then bending moment at C. Bending moment at C, then take a section at C, then observe right side, you are seeing one force which is causing moment at C. That force is 800 and that is causing moment with the distance 0.8. Right? That is 0.8. 800 into 0.8 is 640. 640. Now, this 640 is positive or negative? This force is causing this direction. This direction is resembling with this force, this notation. Therefore, it is negative. This is negative. Here it is negative. Correct? This negative 640 Newton meter. Over. Now, I will come to the other section, that is bending moment at B. Bending moment at B means this is a section, observe right side. Two forces are causing moment here. The first force is 800 is causing moment with the distance zero point 0.7 plus zero point 0.8 is 1.5. 1.5. Right now, this 800 is causing moment in this direction, that is resembling with this direction. Therefore, that is negative. And another force 500 is also causing moment. Therefore, 500 moment is causing moment with the distance 0.7. Okay, and this force is also in this direction, that is resembling with this notation, negative. Therefore, the answer is 800 into 150 is 1200 minus 1200, and 500 into 500 into 0.7 is 350. Both are minus, therefore plus 1200 is 1550. 1550 negative. Right? Now this is the answer at B point. Now coming to bending moment at A point. At A point means, we'll remove these all. At A point I have to take a section. This is my section. Then observe at right side. Observe at right side, these three forces are causing moment. Now the first force is a 800, which is causing a moment with the distance this one, this one, this one, 2 meter. Right? Then another force 500 Newton is causing a moment zero point 0.7 plus 0.5. This is a 1.2 meter. Okay, then another force which is 300 Newton is also causing a moment with the point 0.5 distance. Okay, now this is negative, this is negative, this is negative. Therefore, 800 into 2 is a minus 1600, minus 500 into 1.2 is a 600, minus 300 into zero point 0.5 is 150. Then the total answer is 1600 plus 6 plus 1.5, that is 2350 Newton meter. Check the answer. Okay. Now I will draw the shear bending moment diagram. This is my reference line. Then at this point bending moment is 0, 0. At this point C point is a 640. This is 640. At this point it is 1550, 1550, 1550, and this point is a 2350. So 2350. Okay. Now no load triangle, no load triangular, no load triangular or inclination. You know, this is your negative, negative, negative bending moment diagram. Over. Right? We'll go to the next problem. The next problem is this one. Okay, first observe whether the diagram is right or wrong. 3 kilonewton load is a point load. 2 kilonewton per meter is the intensity of this UDL, and this distance 0.25. This is 1 meter. 1 plus 2 pi 0.25, 1.25, and this 0.25. Therefore, total 1.5 meter. That the diagram is right. And the points are given A, D, C, and B. Okay, no need to give names for the points. Okay, done. We'll go with the shear force diagram. Okay, this is a cantilever beam, therefore no need to determine support reactions. Directly you can solve the problems. The first one is shear force at B. At B, this one. Okay, at B you are considering and observing the right side, you are seeing nothing, 0. Then second, shear force at C. At C you cannot take because point load is there. Therefore, you have to take left of C. Okay, left. Sorry, first we will take right of C. Cut, 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 cut. First in that. Right? Now look at here. This problem is given. First we have to analyze this problem. 2 kilonewton per meter. 3 kilonewton is a point load, and 0.25, 1.25, 1 meter, 0.25. Right. Legends will solve this. Before solving this problem, we have to write a free body diagram. Free body diagram for cantilever is not suggested, and support reaction for cantilever is also not required. But UDL is given. That UDL we have to convert it into point load. For that we have to do some work. Now here the legends, what they do is they will convert the entire UDL into one point load. Okay, but that is somewhat difficult. I always prefer to split this UDL based on the points given. Here the points DC is a one point and CB is another one. Therefore, this is a one point load, which is this is one UDL between C and B. Therefore, this is converted. Intensity is same from D to B. Intensity is same. What is this one? This intensity is 2 kilonewton meter. 2 into 0.25. 2 into 0.25 is a zero point 0.5. Okay, this zero point 0.5 kilonewton is converted UDL. Okay, converted UDL. What distance? This distance is 0.125. Remember, okay, that is converted. When you become a legend, no, then you can consider the entire UDL as a one UDL and you can solve. But now we are learning, therefore this is a 0.5 kilonewton. This UDL is converted. Now from D to C, 2 kilonewton UDL for 1 meter is there. That I will consider. 2 into 1 is 2 only. That 2 is acting somewhere here. That is dotted line. This is 2 into 1 is equal to 2 kilonewton. This is 2 kilonewton, right? Where it is acting? That is acting from here, 0.5 meter. Okay, half of the 1 meter. Now, this is what problem analyzed. Okay, now no need to see UDL. Forget about UDL. UDL is converted into point load. Therefore, just ignore UDL and proceed. Now, the first one. Support reactions are not required for cantilever. Remember. Now, shear force at B. Shear force at B. Then observations we will make this side. Okay. Observations will make right side. When I make observations right side, nothing is seen, therefore 0. Over. Right? Now coming to shear force at, okay, at C I cannot write because at C point load is acting. Therefore first section I will take right of C. Shear force at right of C. Shear force at right of C means this one. Shear force at right of C. Then observations made right side. Then what forces you are seeing? Is there any vertical force? Yes. zero point 0.5 is the vertical force. This 0.5 is resembling with this notation. Therefore, that is a positive 0.5. Positive point. At C, right side is over. Now, I will come to next shear force. Shear force at left of C. Shear force at left of C means this one. Okay, then observations again, right side. Now I am seeing right side two forces. One I am seeing 3 kilonewton, another I am seeing 0.5. And both are downward and both are resembling with this notation. Therefore, positive, positive. The answer is 3.5. Right? Over. This section is over. Now come to shear force. Shear force at D point I will come. Okay, D point I can consider because point load is not there. Now don't think of this force. This is not a point load. You converted into a point load. That is your load, not given load. That's why don't take a section or shear force that point. Now coming to shear force at D point, then take a section at this point. Observe right side. When you observe right side, what you are seeing? You are seeing one force here, vertical force, another force here, and another force here. Three forces you are seeing. 2 is a one force, 3 is a one force, and 0.5 is a one force. Then all are acting downward and all are acting right side downward, therefore resembling with this notation, therefore positive. The answer is 5 plus 0.5, 5.5 over. Right? Now that I will write because I have to save paper. You know, this is 5.5. Now then shear force at A. Shear force at A. Shear force at A means this point. Now I will take a section at that point. Then observe right side. You are seeing one force here that you have to consider. This you have to consider and this one. Therefore the same thing. 2, one force and 3 is another force and 0.5 is another force. And both all are acting downward right side. Therefore they are positive 5.5 over. Shear force is completed. Now we'll draw that shear force diagram. Okay, now correction. Now at this point B point, at B point 0, 0. Now at C point 0.5 and 3.5. Very important. 0.5 and 3.5. 0.5 is here, 3.5 is here. Next at D point 5.5. This is 5.5. Okay. Then at A point again 5.5. Okay. Shear force variation when there is no load between 2 points, rectangle. Shear force variation when UDL, then this is inclination. Then shear force here, inclination. This is your shear force diagram. Positive, positive, positive. This is SFD. Over. Right? Now we'll go to bending moment diagram. Yeah. Now the first one, bending moment at B point. Bending moment at B point. When you consider bending moment at B point, then take a section here, observe right side, you are seeing nothing. Then bending moment at C point. Directly you can take at C point because there is no moment. No, rules is for moment. Two section rules is for moment. This is a C point is a point load. Therefore, now at the C point you take a section. At the C point you take a section. Look at right side. When you see at right side, a point 0.5 force is creating moment. Point 0.5 force is creating with the moment with a distance 0.125 meter. Okay. This 0.5 force which is creating moment is in this direction, that is resembling with this force, that is negative, therefore minus. The answer is zero point 0.5 into 0.125. This is 0.0625. 0.0625 is a negative moment. Right? Over. Now we will rub those things which are not required. Okay. Now we'll go to this C point is over, D point will. Now we'll take a bending moment at a D point. At D point means this is a section. Look at right side. When you see right side, you are seeing three different forces. The first force is a two force. This two force is causing a moment. This distance is zero point 0.5 meter. Right? This distance is zero point 0.5. Therefore, zero point 0.5. Right? And that is sorry, this direction that is resembling with this one, therefore that is negative mark. That is negative mark. Right? Now 3 kilonewton is also causing moment. That 3 kilonewton with the distance, which one, how much? It is from here to here. That is the distance from here to here. How much it is? 1 meter, perfect 1 meter. Right? That is also negative. Okay. Next, another force is zero point 0.5 newton, zero point 0.5 kilonewton is causing the force, and that distance is, let's show in the top, that distance is from here to here. Okay, na? Then this is 0.125 and from here to here is 1 meter. Therefore, 1.125. This is also negative. Now, what is the answer? The answer is 2 into 0.5 plus 3 plus 0.5 into 1.125. Okay. This is minus 4.5625. Don't rely on my digits. Just calculate with your calculator. Rely on the method. Okay. This one. Next one is, next section I will go. This is all over. Right? Next section I will go bending moment. Bending moment at A point. Bending moment at A point means section here. Then look at right side. Look at right side. When you see right side, you are seeing again three forces with different distances causing moment. Then 2 kilonewton. This 2 kilonewton is causing a moment with this distance. This distance means this is a up to here is a zero point 0.5 and from here is a 0.25. Therefore, it is 0.75 and which is negative. Then this 2 kilonewton is causing a moment from here a perfect 1 meter plus 0.25. Therefore, it is 3 kilonewton into 1.25. Okay. Now, next, another force 0.5 newton is also causing moment. This is from here to here. Here, this cut is 0.125 and this is perfect 1 meter and this one is perfect 0.25 meter. Right? Then the total is 0.25 plus 1 plus 0.125. The total is 1.375. 1.37375. This is also negative. Now you will get the answer 2 into 0.75 plus 3 into 1.25 plus zero point 0.5 into 1.375. Okay. The total answer is 5.937. 5.937. 937. I pronounced there plus, no, don't worry. Minus, minus, minus are there. Therefore, I have to consider, I have to add only, no. Therefore, the units are kilonewton meter. Over. The problem is solved. Now we'll draw diagram. Now look at here. At B, it is 0. At C, it is minus 0.625. 0.0625 minus. And at C, 4.5625. This is 4 point. Right? Then at D, 5.93. This is 5.93. This is 4.56. Now, from here to here, UDL is there. Therefore, this is parabola. Kaun bola? Parabola. Right. Now, from here to here, this is again UDL. Therefore, this is also again parabola. Okay. Now, from here to here, no load. Therefore, straight line. This is your negative, negative, negative SBMD. Over. Okay. Next problem is there. You can solve this one. It's very easy problem, and you can solve this one. Shape, I can give you some shape how shear force diagram will be. Shear force will be something like this. Then after that, again fall. Sorry, you can solve this problem. Some hint I can give you how shear force diagram will be. The shear force diagram will be something like this. Then after that, it will be something, and then okay, this will be your shear force diagram. You can check, cross check the values, you can write. Then the bending moment diagram will be something 0 here, then it will be something here, then after that, here you may have something like this. Okay, now this is your BMD negative, and this is a positive shear force diagram. You can solve this, write it everything here, and you will get this shape. Thank you very much. In next class, we'll solve simply supported beams, standard beams, and next video that beams with the combined loads. Thank you.